Good morning. Welcome back to IT Toolbox. I hope you had a good break. Yeah. And we'd like to wish you all a very successful new year, especially in your studies and in this second teaching block. So today we will carry on our development of web prototyping, and we will be going through some database concepts, because behind any professional website there is some database somewhere. So that's where we are. So in terms of web prototyping, we have already looked at design and CSS, so that's HTML. We have done some PHP that will be marked soon. And today we are going to look at database concepts. And then in a further lecture, we'll be looking at MySQL, which will be allowing you to integrate the database inside your PHP. Okay. But first, a bit of feedback about the first semester and activity 10. So that's the number of student submissions for each activity. So the trend is kind of going down, which is not very good. For those ones, the deadline hasn't really passed, so there's still some hope it's going to get a bit higher. For 7 and 8, the deadline was a bit unclear. So Pushpa and I made the same mistake. We said Monday, but we said the 10th. So to make everybody happy, the deadline is tonight at 11:59. So we give you the benefit of the doubt. I mean, it's our mistake. So hopefully those two numbers are going to go up. But while this one is not too bad, that one is a bit more worrying. Yeah. And that one is the PHP one, so that's maybe the hardest we have had so far. And arguably it's maybe one of the most important ones, because your larger piece of coursework will rely heavily on PHP, and that's something you will be using next year and in your final year as well. Many students do, for example, their final year projects in PHP, so it's really a technology that you have to master. So keep in mind that PHP is important, and hopefully, since I drew the graph, a lot of people have submitted. There's still a bit of time, so maybe make an extra effort. Yesterday we had our first scheduled session with the mentors. I passed in the room and it looked like it was quite well attended, so hopefully some of you had some support for completing activities 7 and 8 through that session. Still, on the positive side, 95 students have passed all the activities so far, so they are on course to get 100% for this module, and they are on course to have passed the module very soon. So maybe in 1 month's time they will have reached the 40%. Would relax a bit, at least not to worry about the outcome of that module. Regarding activity 10 itself, so quite disappointing. I had only 39 early submissions. I was hoping that with the break, some of you would take advantage of it to work a bit on your activities, especially if people who are a bit behind. On those 39 submission, 50% failed. I mean, that's okay. You still have 3 weeks to deal with the issues. And we are going to go through them right now so that you will know exactly what to do in order to pass. So the main issue was question 8. So for people who don't remember question 8, it's about, I asked you to basically to build a computer, choosing some components, and in particular, I'm asking you for the memory sizes of the different components in terms of RAM, ROM, and hard disk. And in order to make you practice a bit your conversion from decimal to binary and hexadecimal, I've asked those memory sizes in different units. And particularly the conversions in binaries were very unsatisfactory. So basically anybody who did it wrong failed the activity. So I'm going, yeah?
Did you have to, when I looked online for this, there was equations and stuff for converting it.
Yeah.
Did you actually have to put the equations, like show off your workings, or did you use something else?
No, just the number.
Just number.
Yeah. So people who failed, usually they failed because of that, so they don't need to resubmit everything, they just need to submit me again by email just the table with the right numbers. Okay. So do you have your clickers handy? So that's a typical mistake that I got in a submission. So it was about the size of the RAM of high-end PC. And that's the size of the RAM in binary. The room number is
5. It's 5.
5. Yeah. So that's the number they came up with. So what's wrong with that number? So is it simply too large that a modern computer couldn't address such amount of RAM? Or is it actually too small? Because we know that binary numbers, they are very long, but when they are converted in decimals, they shrink. So they may look big, but actually they are not that big. Or is it just that that number is not binary, so it's simply wrong? Are there still people voting, or everybody has had their opportunity? Okay, so obviously the right answer is C. In the binary base, you only have 0 and 1. Okay, so any number which doesn't have only 0 and 1s is just not binary. Okay, so the person who submitted that, I mean, there are a few who made that mistake, clearly didn't understand fully the concept of binary numbers. And since it's a very important concept, I failed those students. Okay, so the number should just have 0s and 1s when you are in the binary format, which means it's very easy for me to correct. Yeah. When I see that number, I don't have to think too much. I say wrong. Yeah. So how to do it right? Yeah. I'm going to give you an example. So here, for example, is a RAM memory that you could have chosen. So the size of that memory is 512 megabytes. Okay. So mega in computing science is not 1 million, but it's 1,048,576. Yeah. And a byte is 8 bits. Okay? Because obviously I want the number in bits. Yeah. So now, if I multiply those three numbers, I will get the number of bits in decimal. And now I can convert that number into binary. And I will get a huge number only with zeros and one. Is that clear? Do you have any question?
Okay, did it right then.
Excuse me?
I was wondering if I should use gigabytes or turn it into bits, and I did go for that one.
Okay, excellent. So I send you an email saying you passed? Excellent. Everything is under control. Okay, so that's what you need to do. Okay. Obviously, for converting into hexadecimal, the first steps are the same when you're in decimal, and then I guess you will be using an online converter, which will give you the right number. But you need to be familiar with those units: megabits, megabytes, bit, bytes, and decimal base and hexadecimal. Okay. So, I mean, that's a very important concept, obviously, of computing science. And you know that your course is accredited by the British Computer Society. And that's one of their requirements, that obviously all graduates should have quite a deep understanding of all those numbers that are behind computers. So it's not me being picky, you know, it's industry standards that we have to follow. And that's the number in hexadecimal. Someone asked me for more information about those numbers, maybe to study it another way, maybe not the way I presented it. So I found that blog, which was quite interesting. I mean, obviously there are hundreds on the net, but you may want to have a look at this. Okay, in the comments, many students found difficult to get any information about the ATMs in general, and the ATM which is on the car park in particular. So as I said, you know, you may not find exactly the specs, so use your best guess. Okay, what kind of machine do you expect to be inside that box? You know, do you need the latest high-end computers with super graphic cards which can handle stereo, 3D graphics, and all those things, or you think that an old computer, 3 years old, would do the job? Yeah, I mean that's the kind of reasoning you need to have. And from that, we can say, okay, let's assume that it's that type of computer, and I work from that assumption. Okay, so I don't really care about the exact number. It's more about your reasoning. Yeah. Question 9, I asked you to compare the architectures between the ATM, the mobile phone, and the computer. Someone was not quite sure about what I meant by architecture. So look at the inputs, outputs, kind of memory, storage, maybe speed of processing, that kind of stuff to write your answer. Okay, so hopefully, I think it's not an activity which is too difficult. So I really hope that everybody will eventually complete activity 10, but make sure to have your conversions correct, because I have been and I am picky on that. Okay, so today we, as I said, as part of building our website, we need to have some basics about databases. So the first question is, what are data? Obviously, if it's databases, it's something which is going to be populated with data. We need to have a good understanding of what data are. More votes, or yeah, 38 as last time, 40. Okay. Okay, so most of you chose option 7. Quite a sizable proportion of you chose D. Again, the group as a whole had the correct answer. So I'm going to specify the definition of what data are. Okay. So that's data. And so information, which is really what we are interested in, is data that has been organized. Okay, just having a bunch of paper notes is not that useful. Okay, if it's not organized in a meaningful way, you're not going to get much out of that. Okay, maybe if it's your own mess, you will find a way through it. But if it's not, it's just useless. It's just good for the fire. So information is organized data, and the purpose of a database is transform data, which can be that messy, into something which allow you to make a decision and to take some action. Okay. So initially, you have your data. You are going to organize them in a coherent and meaningful manner, and that's going to provide you with some information. The analysis of that information is going to bring you, hopefully, some knowledge, and using that knowledge, you will be able to take some action. Okay. So the database is really converting data into information so that knowledge can be extracted from those initial data. An example, so data can be typically numbers, okay, or here red, and as such it's not telling you much. You know? Information is, okay, what is the context of those data? Okay, so to understand a bit the relationship between them. The knowledge is using that information you understand what's happening in the world. For example, a traffic light has turned red, and eventually you are going to take an action, which is in this case, stop your car. Okay, so the data is, I see a red light, which is not very meaningful in the absolute. You need a bit of context to convert that into information. I see a red light, I am on a street, and the red light on the side, that's a junction. Okay, that makes the red light meaningful. From that, you will reach some conclusion. Yeah, the road is closed and it's a traffic light, and eventually you are going to take some action. Okay, so the database, as I said, is providing you with information. So we have been using databases for a while, and you may have databases without having computers. So in your opinions, which of those are databases, or are they all databases? So let's look at your answers. Excellent. So almost everybody. So I guess everybody except one person got the correct answer. Well done. So as I said, a database is basically organized data. Okay, so all those systems are a set of organized data. So they are defined as databases. So it's an organized collection of data, and here I have a few examples. I already mentioned the telephone directory, the TV guide, airline reservation system, car registration records, distribution board, even papers in a filing cabinet. Okay, if they are organized in a coherent manner, that's a database. Okay, no need of a computer or a book. Files on your computer hard drive is a database. Maybe not the most efficient one, but it is. Web indices and so on. So databases have changed a lot. So for a long time they've been paper-based, and so you had libraries with little pieces of cartons with instructions, and you had an army of people working in the library, getting the item you are looking for, processing your queries, and doing all that work. But obviously nowadays everything is hopefully computerized. And and there are different ways, obviously, of organizing, even in a computer, your data into a database. Initially, you had a set of files. Okay, all your data were stored into a set of files, and each file hopefully was well documented, so you could retrace the information, the data quite easily. However, initially, you had one file per application. Okay, so if you imagine a small business, a shop, you will have a file with your sales. Okay. So you will, each time you sell a product, you are going to enter the details about the product and the prices you sold it, and you are going to sell that, store that information in something which may look like an Excel file. Okay. And then you have another application which is dealing with the stock in your shop. And obviously, each time you sell a product, your stock is going down. And when you order products, your stock is going up. And in the past, you had another file where you will record what has left your stock and what has been added to your stock. And you had two documents which were completely independent from each other. Okay? And maybe you were even using different applications. Maybe you wouldn't use Excel because Excel, you need to be a bit computer literate for that. So maybe you would use some nice application which allow you to enter values in a form, press a button, and store the things. So in the past, you may have several applications dealing with different aspects of your business. Those applications will not speak to each other, and the data would be disconnected. Okay? And the risk in that situation is that obviously each time you make the sale of one product, your stock is going to go down by one. Okay, so what can be seen as two different parts of your business actually are intimately related. Okay, so you can imagine that how many times you are busy you have with your customers, you focused on the sale program, and you forget to update the stock program. So at the end of the day, you have sold 10 articles, and your stock have only been reduced by 8. And the two systems are starting to diverge, and there is no coherence into the data which represents your business. Okay? And so in order so the limitation, as I said, that data are separated, and they are isolated. Okay, there are no connection between them. Data are also duplicated. Okay, each time you are selling something, you have the name of the product, and in your stock you have also the name of this product. So if you want to update a product, okay, the new version of the product, you have to update it in the two systems. Whereas it's the same product, and in principle you would just like to update it once. You are at risk of having incompatible file formats, and security is not something which is handled in any way in such type of systems. While in a database management system, you have one system, a unique system, which is your database management system, and the sales and the stock are two applications part of the same system. So it means that the data are combined, are in a unique place in the database. Okay? So when you change things through one path, for example, the sales path, automatically your stock is going to be updated. Okay? And each product is defined only once, whereas it's in the sales or in the stock applications. So a database management systems, that is abbreviated by DBMS. So it's a software which allows you, first of all, to define a database. Okay, it's very important to know what is the kind of data you want to store in a file. So you can define it, you can create it, and then you can maintain it, and you can access it. Okay? That's all the functions performed by a DBMS. So obviously you are able to add, modify, delete data. Okay, so that's updating values in your database and adding values, removing values. But it's also allowing you to start gathering a bit of knowledge. Okay, the question is, how much items do you have in stock? Okay, so here I'm going further from the actual data. I'm asking a general question about the situation of my stock. So I'm gathering knowledge. Okay? And if I discover that my stock is empty or low, then I can take some kind of action, which would be to reorder some products. Okay? So using your database, first of all, you design your database, you create your database, you maintain it, you update it with new values, you enter new products, you can delete and so on. And then you are able to ask questions about the data which are inside. And not only you ask questions, but you get answers. And those answers are called reports that summarize the output of your question. So using such a system, obviously we are dealing with all the limitations of the file-based system that we saw early. So you minimize data redundancy. For example, the different products are only defined once and for all. Data are consistent. For example, each time you have a sale, the stock goes down. Data are all integrated within a single format. So if you want to have an understanding about your business, you just ask a question at one place, and that will give you hopefully an overall view of the situation of your business. You have integrity of your data, so it allows you to have password protections. Some users will be allowed to just read the data. Some people will be able to modify the data, that kind of stuff. Modern database system obviously deal with security as well. And also it follows standards, which means that you can update from one database system to another, and hopefully you don't have to re-enter all your data. There will be a way to export and import your data. So among the types of database management systems, the most popular one is called the relational database model. So it was designed in 1970 by a British engineer, Todd. And the seminal paper where he presented this new way of organizing the data is called a relational model of data for large shared data banks. As I say, it's very popular. It has been the most successful database model so far. And it has been very successful for many reasons, but one of them is it's based on mathematics. Okay, so there is some kind of mathematical proof that what you are doing is correct, that data are not duplicated and so on. Okay, so there is some evidence. It's not just, yeah, I believe that it's going to work. No, the math tells you it does work, okay, which is quite reassuring when you are dealing with maybe millions of pounds, know that your system is based on mathematics. Another reason why it has been very successful is that the concepts are very simple. Okay, it's very powerful, but it happens to be very simple, which is great. So basically, a database within this paradigm of relational databases is just a collection of tables, okay? And your data are stored in tables. And between those tables, there are some kind of connections which must be logical. Okay? So that's the only two things you really need to know about that type of databases. Tables which are connected in a logical manner. So what is a table? Obviously, it has columns and rows. And the columns are called fields, and the rows are called records in the database jargon. So a field, which can be also seen as a property, gives you a specific characteristic or a descriptor of an object. Okay. So for example, here we have a table for employees, and we have a field with their taxpayer ID, their last name, first name, phone number, address. Okay, so there are independent characteristics which define a specific record, in this case, a specific employee. Another very important thing is that each table has what is called a primary key. Okay? So a primary key is a very special field. It's a field which will uniquely identify any records. Okay? So it's a value which is never going to change and is going to be unique. Okay? So that's the way you are going to recognize, in that case, an individual. Okay? So you are not going to recognize an individual from their address. Okay? Many people may live to your address, and you may change address. Okay? So that's the address where you live is not going to.
So basically, every single table, all the tables basically have this ID which matches like all collections of data. Then.
Yeah, this ID is the key to your table, and it's using this ID that you are going to connect the tables together. Okay. So the choice of that ID is very important. So as I said, you couldn't use the address because several people live at the same address, potentially, and people move address. Okay? Same story with the phone number. You may change phone number. You couldn't use the surname. Many people have the same surname as you. You could say, yeah, but I can combine surname and first name. Okay, it does reduce, but you will still find people with the same first name and surname. Moreover, you can change surname. Some people get married and decide to change their surname. And some people don't like their first name for some reason, or don't like their surname, or become rock star, and they decide they want to change it, or an artist, or what sort. So those values, which maybe in normal life seems to be identifying a specific person. Okay, you know me as JC Nobel or JC, and for you JC is that very specific person. But actually it's not enough. Okay, here we are based on a system based on mathematics, and mathematics tells us that's not good enough in order to define precisely a person. Okay. So that's why when you join Kingston University, you get a K number. And that number will never change. Okay? You can change course, you can leave university, come back in a few years' time for doing a master's or whatever. You will still have the same K number. Okay? That's for the Kingston University database. Kingston University relational database. Okay, that's your identifier. Okay, so it's not because we are impersonal and we want to call you using a number instead of your name and surname. It's because that's the only way of identifying you in a very unique and precise manner. Okay, so that's really key in a relational database, is this primary key. Okay, so sometimes you just have to make it up. Yeah, you didn't have a K number, you arrive here, we give you a K number. And apart from the database system, it's not of any use. So once you have your system, you can have queries. So here you want to retrieve some information from your database. So one level up from your data. And for example, you want to, if you are in a company, you want to have a query. Who are my employees who are paid with the minimum wage? That could be a query. Or who are the employees who live in Kingston? And obviously those queries can be made in different manners. And the most common way of doing it is to use a query language which is called SQL, or a variation of SQL. And we will be studying one of those variations in the next couple of weeks. So a query is a request, and a report in the database jargon is the answer to your request. Okay? And sometimes a report can be tailored in a very nice way. So a receipt is a report. Okay, you order a product online, they are going to do a query on their database, produce a piece of paper with your name, the product you have bought, and what mode of payment you have used, and that's a report that automatically they can put into an envelope or convert into a PDF and send to you. So that's a report. So sometimes you do queries in order to gather information that will allow you to get some knowledge, or sometimes the report is the end product. So the receipt and so on that you will pass to your customer or whoever. So now that we have the concept of table and primary key, now we want to understand the second aspect of these relational databases, which is that logical connection between those tables. So again, I have a company, and I have a staff table. So here I have the names of my staff members, their position, their salary, and where they work, because it's a company which, in this case, I have several branches. Okay, and I have a branch table where I have all the different branches of my company. In this case, I have 3 places in London, Aberdeen, and Glasgow. Okay. And while I could have decided to put in my staff table the name of the people, position, salary, and the full address of where they work, it's much more efficient to put that separately. Okay? Because imagine that at the moment John White works in London, and this person has been transferred to the office in Glasgow. The only thing I need to do is to change this 005 into 003. I don't have to look for the address or anything. Or imagine that the London branch is going to get a bit bigger, so I'm changing it's moving in another street. Okay, so it means that for all my employees, if I was using only one table, I would have to update the branch address everywhere. Here, the link to the branch is not changing. John is linked to the London branch, whatever the address of the London branch is. If I change the address of the London branch, I just change those 3 fields. I don't have to touch anything about the staff because John works in the London branch, wherever the branch is. Okay? So that allows you not to make mistakes, because if you have only one table, maybe you will forget to update the address where some of the employees work. Maybe you are going to type the addresses in different ways. Okay? Here we have used an abbreviation of road, which is RD. You can imagine that different people will write it a different way. Some people will just write road. So you will have people which will be at 22 Deer Road and people at 22 Deer RD. And then when you look, you make a query, you say, who are the people working at 22 Deer Road? You will miss all the other ones. Okay? So it's about consistency and not duplicating information. There are many people working in that branch in London. We just write it once. And that branch is represented by a primary key. And we just use that primary key to link that data from another table. Okay? So that's the concept of relational databases. Independent tables that are connected through primary keys. Yeah? Any question of that? No? Good. Okay, so there are many database management systems around. Okay, they all have some very nice and fancy logos. You may have heard of some of them. I mean, I guess most of you have used Microsoft Access, part of the Office package. Is the least professional one, but it's already powerful enough to deal with domestic applications. But I don't think I would use that within a business context. You have a couple, MySQL and PostgreSQL, which are open source, so obviously that's quite attractive. You have also others which are commercial systems, so either associated to Oracle, Microsoft, or IBM. Some of you will have already noticed that the letters SQL tends to appear regularly. Out of all those systems, we have already one SQL here, another one here, and a third one here. Okay. So, in your view, and you may not have any idea, so you just guess, what is the most popular database management system? Okay, so nobody had heard about the IBM system, so it was obviously not popular to you. A majority is going for MySQL, Oracle and Access still have quite a few people supporting it. Let's look at the actual data. But it's not bad, it's not bad. Okay, so there's a website publishing every year a ranking of the most popular systems. So I've been following it since 2014, which is interesting to see what are the systems which are becoming more and more popular. Because in the IT world, you need to be at the edge, and you need to understand what is the system which will be popular in 3 years' time. You are studying databases. You don't really care about what is the most popular today. What you want is the most popular when you will have graduated and will ask for a job. You want to be ready for that one. Okay. So it's interesting to see how things are evolving in the world of, for example, databases. So that's what I've been following them since 2014. And interestingly, the first three, the ranking has just changed. Okay. Number 1 is Oracle, number 2 is MySQL, and number 3 is Microsoft SQL Server. Okay. That's been the same for the last 4 years. Interestingly, we have MongoDB, which was number 6 in 2014, and which has gone up to number 4. So that's maybe a system which is worth having a look at. Okay, is it going to carry on going up? PostgreSQL went a little bit down. The same things for the IBM system. Cassandra was number 10 and now number 7. Access was 7, now 8, so it's kind of stable through the years. Redis, not much change. SQLite going down a little bit. Okay. So what is also interesting is what kind of database models is used. So I've put in bold the relational databases. So that's the one we have been looking at. Tables which are linked through primary keys. And you see that it's the large majority of the systems are based on this relational database system. Interestingly, MongoDB, the one which is coming, which seems to be coming, is using a different system. Okay. So that's maybe of particular interest. Another thing which is interesting, that the SQL again is quite present. There is some SQL flavor in number 2, in number 3, in number 5, and in number 10. Okay, so it looks that SQL is also something quite important in the world of databases. So that's just the ranking, but we don't know yet if there is a big gap between the number 1 and number 2. Okay, maybe number 1 is 90% and number 2 is 9%. And so number 2 is not maybe that relevant. Okay, so ranking is not enough to tell us what is really important. So here are the percentage of usage for the different database systems. So it's quite interesting to see that the first 3 are doing basically 2/3 of the market. Okay, and although MongoDB is going up, it's really a tiny share of the market. So it's not yet competing with the 3 big ones. And the 3 big ones are roughly of the same importance. Okay. although Oracle is number one, there's not a big difference between Oracle and MySQL in practice, in the terms of users. So, as I said, there are many SQL-based systems, and we will be learning, bless you, we'll be studying one of those systems, MySQL, which happens to be number 2 in the list, and being one of the major players in the world of databases. So we will be studying that in a coming lecture. Okay. So how do you design a database? Okay, because you will be designing databases, you need to create those tables. So how many tables? Okay, because if you create only one table, it's not very useful. As we said, we need to have this primary key to take advantage in order to reduce the redundancy of information. So to design a database, usually you look at what is the current way of storing your data. Okay? Or if you are having a business which is only paper-based, what type of papers do they have? You know, they have product order forms, they have bills, they have receipts. There are different types of papers, and those types of papers should help you to already have some kind of, it means that there are already some structure in the data that, for example, that business is collecting. Okay, so obviously you are going to take advantage of that structure in order to build your system. Obviously, since in that case it's a paper system, there's a lot of redundancy, so you may decide to split one piece of paper into a set of tables, because you can take advantage of, for example, as we said, the branches of a company. So you will need to define all the fields that you need for your data, because that's how you are going to store your data. So everything which is important needs to have a field. And you want to avoid repetitions, and you can prevent that using some secondary tables where you will have information that you will just link to in order to repeat it. Obviously, you want something simple, because if it's too complicated, nobody will understand it. Okay? Because it's nice to build a system, but you need to be able to maintain that system. You know, if you need to add an extra branch, it shouldn't be leading to redesigning the whole system. Oh, it's just adding an extra line in a table. That's okay. And what is obviously key is to create those primary key and making sure that they are unique identifiers. And that's a very important rule of computing science, is if you have garbage in a system, you will get garbage out of that system. Okay, so you need to organize everything well, otherwise you will not get anything out of it. So a first way of ensuring that your data are consistent and of good quality is at the time of the data entry. Okay? First of all, there are some fields that are essential. Okay? Because you may have a lot of fields for a given product or for a certain line of products, but some of them may be optionals and some are essentials. So when you build an application, you must make sure that a new record can be entered only if all the essential fields have been entered. Otherwise, the system should say incomplete data. That's not going into the system. because you need to make sure that your system has everything which is required. Also, you want to make your data as much entry foolproof as possible. Okay, if you are entering phone numbers, you are expecting digits. Yeah, I mean, very often people make mistakes. They put an O instead of a 0. Yeah, it happens. If your system is well built, if someone put an O, the data will not be acceptable. You will get an error message and will say, no, it's not a phone number. Okay. Or you're expecting a British phone number, you're expecting, is it 10 digits, 11 digits? You know the number which is expected. So if there is or there are digits missing, the system should tell you. It's not an acceptable entry for that data. Also, you want to prevent error of spelling, for example. I mean, when you are registering on most websites, they are not asking you for your address anymore, your street number, your street name. They're asking you for your zip code. And from that, they retrieve so there is a database behind. From all the zip codes, there's the street names. Yeah? Because it's less likely to make a spelling mistake. So just enter a zip code. Oh, it's not acceptable. Try another one. But all the street names will be written the same way. Okay? Or using pull-down menus. Okay? In which year are you as a student? You don't allow people to enter the number because are you level 4? Are you first year? Are you know? It can be confusing, and everybody will enter something different, and then your database is not going to be consistent. So better to just have a menu, and you have to pick one of those options. Okay. So when you are building a database system, you need to make sure that the risk of entering wrong data is limited to the minimum. Okay. The risk is limited, yeah, to the maximum. So try to use all those kind of techniques. Also use a barcode scanners sometimes. When you go to the library, you are scanning your card. They are not asking you to enter the number. How many times would you make a mistake? And also it would take more time. Okay, so barcode scanners usually don't make mistakes. So that's a good way of entering data. Okay, so that was a brief introduction about databases. And as you know, what I'm more interested in this module is the practice. So that's why we have an activity on this. So you remember a long time ago in another galaxy, you were asked to produce a blog. Okay. And a blog is a system where you enter data are recorded, you can retrieve that data, you can delete that data. So hopefully and obviously there's a big database system behind that blog. Okay. And you have used WordPress, so everything was nice and easy. The word database was not even mentioned anywhere. You just had to click the right buttons and you got your blog. So it means that behind, WordPress did a lot of work and created a whole database organization. It created tables, primary keys, and connections between those tables. Okay. And so what I want you to do as part of activity 11 is to study that. Okay? Now that you have a basic understanding of how a relational database system works, let's look at a real one, yours, that you have created. Okay? So in this case, I ask you to go to your blog and look at what is behind, what is a database, what are the different tables, what are the different fields, how is the information recorded. Okay? So obviously for those who didn't complete, I think it was activity 3, they will have to create quickly a database using WordPress. But the one who have done it already, you know it's not a big deal. Yeah. Obviously, there will be also a short quiz, because we have gone through the main concept, but I would like you to do a bit of research in order to go a bit deeper into this topic. And finally, I want you to create your own database from scratch. Okay? Because so far, WordPress did all the work for you. Okay, that was nice. You were not even aware that there were a database. Okay? You want to become IT professionals, so you need to be fully in control. Okay? So there are different ways of creating a database. I would say that there are at least 3 ways. One way is to be the database user. So that's the person using WordPress. You create a database without being aware of it. Okay? So that's not really demonstrating that you are an IT professional. The most advanced way is to create a database by writing commands, okay, using some form of programming, which will be creating a database. And that's what you can do using, for example, MySQL that we will be seeing in a few weeks. And then there is an intermediate way, which is provided with your web server, where you don't do programming, but you are in full control of the table. Okay, you say, I want to create a database. I want to create a database. In that database, I want to create 3 tables. For table 1, I will call it customers, and I will have 4 fields. And the first field will be my primary key. My second field will be surname, and so on. And I will have another table which will be products, and so on. Okay? So it means that you don't need to have the programming skills in order to create the database, but you need to have the design skills in order to create them. Okay? Because the creation itself is just clicking in the right button, pressing the right buttons. Okay? So that's what I want you to do here, is to create your own database. So the database can be on anything you want. Okay? So a database with your favorite songs, favorite food, favorite football team, favorite or least favorite books or whatever. Okay? So not something very complicated, and you will be seeing the instructions in the brief, but I would like you to create your own database from scratch to have a clear understanding about those tables, those primary keys, and also the format of the different fields. Some fields will have a format which is text, free text. Some fields will have a format which will be just numbers. Some fields may have a format which is Boolean, yes or no. Okay? So that's the type of skills and insight you will get creating your own database. Okay? So, as I said, if you hadn't created your WordPress blog in Activity 3, now it's time to do it if you want to complete Activity 11. And as I said, today it's about databases, and we are creating it from scratch with using the interface that your web service is providing. In a few weeks' time, we'll be using MySQL, so the programmatic way. And that's what will be expected for your final assignment, obviously. So thank you very much for your attention, and have a good week. And I should be marking your